Hello everyone. Today is day number 15 um, of our 30 of our challenge of solving 30 machine learning problems in 30 days. So we have solved these many problems and we are on this problem today. It says we have to predict the house prices with XGBoost model. If we see, we have already done something similar, like predict house prices with linear regression, simple linear regression. Before we start, let's understand what we have done so far. So we have understand the basics by applying to the real world data set. uh, Now this we are starting the third week, and this time we are, I mean, going into complex algorithms and techniques that we have, I mean, over the previous learnings. So today we are on this XGBoost for house prices. So let's start. Here it is day 15 and here is the problem. Okay, let's wait for ChatGPT to generate the response. Oh, nice. So it is telling me about why XGBoost, and then data set we can get from where. Okay, let's start. So it says, great, let's tackle day 15's challenge. Predict house prices with XGBoost. This problem focuses on using XGBoost, which is a powerful machine learning algorithm for supervised learning task. Okay, so yes, this is a supervised learning problem, and this is an advanced algorithm, and particularly regression in this case. XGBoost is known for its performance in Kaggle competition due to its speed and accuracy. So it is going to be a very interesting algorithm because according to Kaggle competition, it is known for its speed and accuracy. Why is XGBoost so boosting algorithm? XGBoost is a boosting algorithm that builds decision tree in a sequential manner where each subsequent tree tries to correct the errors of the previous one. Okay, I guess we did something similar, right? We did gradient boosting algorithm, and it was something similar where it was building decision trees on the mistakes of the previous decision tree. Decision tree. So I guess XGBoost is doing the same. XGBoost is boosting algorithm that build decision trees in a sequential manner. Okay, where each subsequent tree is trees to correct the errors of the previous one. Okay. Uh, Performance. It's efficient. Okay. Handles missing data well. Okay, and can outperform other models on structured data. Okay. So this is going to be an advanced model. Flexibility. It allows regularization, which helps reduce overfitting, make it robust for unseen data. Okay. Dataset suggestion. We can use the famous Amin's house dataset or Kaggle's house prices advanced regression techniques dataset, which is widely used for this type of problem. Let me see which type of dataset we have used for our day one problem. We use Boston housing from SQL. So let's use this from the Kaggle and see. Okay, this is the, and if we go to the data, and if I search this, order PID, sorry. Mm, oh, so this A stands for America's housing data set. Oh. Mhm. Mhm. Okay. Okay. I will. Uh, what I'm looking for. I'm looking for a single data set, not having one a complex one. Mm, let me ask. How do I get Emmy's a data set? Mm, mm, I guess you can hear the meow meow of my cat. No, beta. No. So he's trying to move the mic. So yeah, I'll go ahead with this one. This seems like a little valid. I don't have to go and yes. Okay, wow. So I cannot download it directly. Wow. Such a great way they have implemented. Okay. So let me go and search the data here. The link is not clickable. Can you give separately? So we've got the data for this one, right? So I'm going ahead with this one. Uh, the AIMS housing data is a well-known data set in the field of machine learning data analysis. It contains various features and attribution of residential homes in AIMS, Iowa, and US. The data set is often used for regression tasks, particularly for predicting housing prices. Okay. And how is Boston housing? How is California housing from Scikit-learn? Is that too simple for using XGBoost or good? So let's ask why I should have asked this before, because then we will be able to better. Yes. Okay. So it says the goal should be to use the this one because it is more complex. So okay, okay. Let's go ahead and use this one. Okay. So I have downloaded it. Let me go back here, and I can see it here. Let me go to my PyCharm and move this downloaded dataset Ames housing to our dataset folder, and you should be seeing it. And let me mention things here. I'm downloading the dataset from here, and the problem is this. So let's start. Uh, Let me load few libraries and tell Panda about how the our data is looking as PD. And step one is load the data. Data uh, pd dot read CSV, and it is dataset and aims housing dot CSV print data dot info head clear and not run this file, which is day 15, and this is how the data is looking. I'll say thanks. I am going ahead with M's housing dataset. Also, I have downloaded it. Let me move this to up so that you can see what I'm typing. So yes, I also have downloaded it from Kaggle and placed it in the dataset directory of my project. Here is how it is looking. Let's start with coding. Okay, so yes, start importing libraries required for data manipulation, data building, and evaluation. So we will be here. This we have have been using a lot, using for the first time a lot, used use a lot, and use this to create heat maps. We have done this step already. So we have to do this step called pre-process the data. So step number two, pre-process the data. And before that, let's import the libraries. Import numpy as np from sklearn model section. Import test split from sklearn pre-processing. Import label encoder from sklearn. No, from x XGBoost. Oh, we don't have. Okay, so let's install this XGBoost. So I'm recording this. I'm solving this problem early in the morning, and I don't get disturbance from outside. I've closed the door. Now my cat wants to go out. So yes, XGBoost import XGBoost regressor from sklearn matrix. Import mean squared error. Import matplot.py plot as plt. Import cbon as sns. So let's go to the step number two, reprocess the data. Yes, handling missing values by filling them with median of the numerical columns and none for the category. Okay, so for categorical columns like gender, where the data is going to be from a category like a set class, like male, female, trans. For them, the missing value we will handle with none. And for the numerical columns, we will handle the missing value with the by filling out the median. Okay. Okay. Can you give me a second? Let me go and yes, just give me a second. Let me go and open the door so that my cat can go out and you should stop hearing meow meow. Thank you very much. My cat was hungry actually. His name is Green. So Green was hungry. Let's resume. So, yeah, it says while pre-processing, we have to handle the missing values, and the categorical one we will handle with none. The non-categorical we are going to handle with the median. Let me go and revise what median is. Median is the middle value of the set of a data set. For example, here the median is 6. Okay, the middle value of the of a data set. Middle as in not from the position, as in if we place it in a ascending order, sorted way, the middle value is going to be the median. And once done, encode categorical data. If you remember, we have done encoding before also. We have used on one hot encoding for our categorical data. So today we are going to use label encoder. We will understand how to use this label encoder. and how is it different from the one who hot encoder, and then define the target variables, sale price and features. Okay. Once done, we will split it. Then we will train and build and train our model and predict and get the error and then visualize it. So let's just simply ask. So first, let's handle the missing values. First is handle missing values. Um, what we have to do? Fill numerical missing numerical values. Missing numerical values with it with the column median and fill categorical values with none. Now, when let's start. So what we have to do, we have to use this data dot fill and missing values, and here the okay column, if data column type is 0, if data else, okay, none if the data type is 0. Okay. Hmm. For each column, if the column dot t type is 0, then none, else data, and for the column, median. Okay, and we are going to do for columns in data dot column. So we are going to iterate. Let me go Python way. This yes. So for all the columns in the data, if the column type is this, it is going to be none. If the column type is not a categorical data, then it is going to be the median. So I just want to see the info here so that we can understand the types and run the file again. Oh, I have an error. Okay, so it expects a second. In place true. Okay, run it. Oh, I'm getting this. Okay, We are getting this. The error you are seeing is related to installation of XGBoost on macOS, where the OpenMP runtime is missing. This runtime is required to enable parallel computing, which XGBoost uses for efficiency. Okay, for parallel computing, it requires this OpenMP, and we don't have that. So let's do this. Okay, it is done. Let's run the second command. Let's install it again, and let's run this file. See if we are going to get the error. Line number 22, we are getting an error like here. Let's comment it, and so we are not getting the death error at least. So here, if we see for non-categorical data, the data type is this object int float. Okay, thanks. Now let's come back here. If we are running this, so what error are we getting? Oh, so we have this, getting this while filling missing values. So it is. So we are not handling the float ones correctly. Contains categorical values RL, RH, which cannot be directly used as input to model like without encoding them. So you can either convert. You can use on. Okay, correct. So why is it doing? Because these are containing the categories which are so could not convert into float. Occurs because okay, could not cover because mm, contains categorical data which cannot be directly used as input to a model like SGBoost without encoding the value. No, but we are not even training the model, right? Okay, so it says uh, first convert the what it says first we have to encode it. So we have already learned about one hot encoding, how it performs. So what problem number 12, as in the day 12's code, we see that we have already explored what one hot encoding is. So yeah, in detail what we see, if we have to replace the classes like e- uh, 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 class eco will be transformed to three columns: class business, class eco plus. And for the columns where the eco was selected, it will look like 010. For the columns where business was selected, it will look like 100. For the columns where eco plus was selected, it will look like 001. So yes, this is what one hot encoding is. Then let's see what this is. If there are larger number of categories, you might prefer doing label encoding. Why? Because This creates individual columns, and we need to see how many. Let me close it. Let me close it. Open my data again, and if I get the terminal back, I should see we have so many columns, right? So it is going to, we have so many columns, string values, which is like categories. Here, for example, float, object, this heating, electrical, first floor. No. So I see we do have a lot of fields which can be pool area. No, this isn't gadget. Okay. So I do see that we have a lot of string fields, categorical fields. So if we use one hot encoding, uh, it will end up creating more columns. So it is going to be a lot of features introduced. So I think we should go ahead with using label encoding for because of the complexity of our features. So if there are large number of categories, we might prefer label encoding. Um, how it works, and after doing that, we can fill in the missing values. So I we have already explored one hot encoding in on day 12. Also, I see today's data set is complex. I feel we should go for label encoding. Can you please explain in easy words what it is and how it works? Okay, let's start. So this label encoding is a technique used to convert categorical data called labels or categories into numerical values. So that machine learning algorithm can um, process them. Categorical data such as MS zoning in your data set often contains value like RL, RM, C, all, etc. Since machine learning and models cannot work directly with these text values, they need to be converted into numbers. Yes. So how does this label encoding works? It assigns a unique integer to each category. For example, if you have MS zoning column in with categories like RL, RM, C, all, the encoder will map them to integers like RL will be mapped as 0, RM will be mapped as 1, C, all will be mapped as 2. This means that every time the model encounters these labels, it will treat them as numbers instead of strings. Identify the categorical column. Identify the categorical columns in your dataset that contains text or labels and code them into this number. Okay. And why we use label encoding? It is simple and fast, especially when you have original categorical data, ordinal categories. That is, there is a meaningful order between categories. Okay. However, for non-ordinal data, I don't know if our data is going to be ordinal or not. It can that means there is no order. It can introduce bias because the model might assume that the higher numbers means more important, which might not be true. Okay. Um, so for R this type of data where RL for row number one, RM for row number two, C all for row number three, it will be converted as 1 0. So this is 0 1 2. Okay, 0 1 2. Now one thing is, um Use why when to use label encoding, it says. So we must use label encoding when the categorical features has no ordinal relationship. That is when the number of categories is relatively small. For non-ordinal or high cardinality data, okay, many categories. Okay, let me ask. I think so. It says for non-ordinal or high cardinality, one hot encoding is often preferred to avoid introducing false ordinal relationship. Now I'm thinking, uh, like from this, how many are looking like categories? This is the info of my data set, Ames housing data set. From the Ames house data set. Uh, and this is the head. I see a lot of information like here, right? This is the head. I see a lot of string fields. I don't think with the description you have provided, label encoding is good for this data set. What do you say? What do you say? So yes, now we do understand what label encoding is. So it converts into labels like, for example, in ordinal 1, 2, 3, 4. But it can create confusion because the model can assume that the value like 2 has higher priority than the value 0. And also it says that for high cardinality, that is many categories, why we should use one hot encoding is often preferred because we will avoid the introduction of false ordinal relationships. That same thing that I've told you. Yes, given the complexity of arms housing dataset and the large number of categorical features, many of which have no inherent ordinal relationship, label encoding might not be the best fit. Okay, so we will go and use one hot encoding. And if someone wants to know how it works, they can always go and check out the video for the day 12. Also, I have just explained here. So yes, pre-process the data. Uh, what we are going to do? Uh, Encode the. Here also did we handle? Yeah. What we encode the categorical data using one hot encoding. So what we are doing, first we will do, the data is going to be data dot sorry pd dot get the means. So so it is going to be encoded, data encoded, and we are going to create the data and drop first true. I remember we did shallow copy last time and we got the error. So you might have to do the recopy. No, no, no. This was not the thing. Yes. So we have to do this. But I guess we have to drop the error. Drop. We should be dropping the. We should drop the target before encoding because this will encode the target also. Let's go back and see what are we doing with the target. The target is going to be sales price. So let's remove it and then sales price. What is this sales price? Sales price is going to be like what? Yes, it is a regression type, right? So it is going to be numerical only. So it is not going to touch that. So we do not have to remove it, as in the encoding will not touch it because it is not a categorical type data. So we will get the dummy encoded. Um, then we are going to do what? And then we will print it. And clear it, run it again, and we see false, true, false for the values where it is null. Sorry, the value does not exist. As in, see, we are seeing new columns created, right? So done. It seems it looks fine. Let's run this again, which is to fill the empty values with none uh, for non-numeric values, or for numeric values just fill with the median. Even after doing the encoding first, remove the below line throws error code. So let's see what ChatGPT has to say. Oh, this only from the data we must do encoded data.